Hey everyone, welcome to Studying with Jen. Today we're going to be doing arithmetic sequences. So what is an arithmetic sequence? An arithmetic sequence is when I have a sequence that has a constant difference between the terms. In this case right now, I'm going to call it b. How do we calculate b? b is calculated by taking t2 minus t1, or it's calculated by taking t3 minus t2. You can say T4 minus T3, but the general formula for B is equal to Tn plus 1 minus Tn. This being the following term minus the previous term. Now the formula a lot of you will use this year is Tn is equal to Bn plus C. Don't stress if you haven't seen this formula before. There is another formula that you are allowed to use, but I'll get to that in a moment. Tn being the general term, the nth term, the general formula, all the same thing. B being the constant difference, n being the position of the terms, C being term 1 minus a constant difference. Now if it's term 1 minus a constant difference, it's term 1 minus a constant difference. C is just technically the term that comes before the first term. Now, a lot of you have used another formula in grade 10 and 11, and you still are allowed to use this formula. I'm just going to show you how we get to that formula. So we start off with Tn equals Bn plus C, and we have C is equal to T1 minus B. I'm going to sub C into this formula over here. Tn equals Bn plus T1 minus B. Now I'm going to make B equal to D, and I'm going to make the first term equal to A. Now I'm going to sub this in, and I'm going to say Tn is equal to Dn plus A minus D. I'm going to rearrange this to make it look a bit better, plus Dn minus D, and then we end up with A, and I'm going to sub out a D. I'm going to factorize out a D, and I end up with that, and that is the same thing as this. And you are still allowed to use this formula. Please do not use it. You are still allowed to use that formula. You can use either one, right? You can use the one with the term before the first, or you can use the first term. So Tn is still the general term, A is the first term, N is the position of the term, and D is equal to the constant difference. You can decide which one you want to use, which one's easier for you. It doesn't matter, you can use either or. Okay, so let's have a look at an example. My best advice for dealing with sequence problems is always map it out. So we're going to map it out like this. It's so easy, and it just makes sure that you're not going wrong anywhere, and it just makes sure you're not missing anything. So how do we get from 3 to 5? We add 2, we add 2, we add 2. Okay, so from 3 to 5, we add 2. 5 plus 2 is 7. 7 plus 2 is 9. Okay, so we can see through observation that it's equal to 2. If you'd prefer to calculate it, and your teachers are a little bit funny about, you have to calculate everything, then do calculate it. So you can calculate it, you can do it through observation, you can do it either way. Equals 5 minus 3, b is equal to 2. That's how we calculated the constant difference. So now we want to figure out the formula for the general term. I'm going to use this formula in this question, but you can also use the other formula. You'll end up with the same answer. Okay, so we have Tn equals Bn plus C. We should also have this formula, right? So let's calculate C first. We have C equals the first term. What is the first term? The first term is 3. So we're going to sub in 3 minus 1 constant difference, 2. So C is equal to 3 minus 2, which is 1. Now we can sub it into our equation. So Tn is equal to B, which is 2n plus 1. Tn is equal to 2n plus 1. That is the formula for the general term. Okay, so B asks us to calculate the value of the 50th term. This is a position, right? So this means where n is equal to 50. So we're going to sub that into our formula. So we have our formula that we've just calculated. It was 2n plus 1. And we're going to sub 50 into n. So we're going to say t50 is equal to 2 times 50 plus 1. So t50, so term 50, is equal to 100 plus 1. Term 50 is equal to 101. And that's the answer. So C asks us which term is equal to 53. So they haven't given us a position. We need to calculate the position. So n is the objective, right? We have Tn equals 2n plus 1. That's the general formula for the term. The general formula that we calculated. We are going to make this part equal to 53 so we can calculate n. So we're going to say where Tn is, we're going to put 53 is equal to 2n plus 1 because we need to calculate the position. So let's calculate n. We're going to take the 1 across. It's going to become 52 equals 2n. Divide by 2 on both sides and we end up with 26. So the 26th term. You don't have to put 26th term, but you can just put 26 and then you'll get your full marks. So let's have a look at this example. We have -5, -9, -13, and -17. First things first, we map it out. Always, always, always map it out. How do we get from -5 to -9? We subtract 4. -9 to -13, we subtract 4. From -13 to -17, we subtract 4. So in this case, I'm going to use d is equal to -4. You can also calculate d by saying t2 minus t1, and d is equal to -9 minus -5. Let's put it all in brackets. That's equal to -9 plus 5. D is equal to -4. Okay, so to calculate the formula for the general term, we're going to use the formula Tn equals a plus n minus 1 d. It's the same thing as using the bn plus c, exactly the same. We're going to sub things in. Tn, a is the first term, so a is equal to -5 plus n minus 1, and d is equal to -4. We're going to say Tn is equal to -5. We're going to sub this -4 into there. It's going to be -4n plus 4. Then to simplify, we just get all our like terms together. We end up with -4n. -5 plus 4 is -1. And that's the formula for the general term. Okay, let's have a look at B. We want to calculate the value of the 36th term. This is giving us a position, right? Which means where n is equal to 36. So we're going to use our formula that we calculated, -4n minus 1. And we're going to say term 36, the 36th term. And we're going to sub in 36 minus 1 is equal to, let me just use my calculator, -144 minus 1, which is -145. And that's your answer. Okay, let's have a look at C. Which term is equal to -73? They haven't given us the position. We want to calculate the position of the term that is equal to -73. So we're going to take, this is our formula that we calculated. We're going to take this part and we're going to make it equal to -73, and then we can calculate the position. So if we say -73 is equal to, so we've subbed -73 into Tn. Then we say -4. We want to calculate n. There we go. So now we can calculate the position of the term. So let's solve it. We have -73. When we move the 1 over, it's going to become -72 is equal to -4n. And the answer to that is n is equal to 18. We divided by -4 on both sides. So the 18th term is equal to -73. We calculated the position. That's the answer. Okay, so let's get onto a slightly trickier example. Here we have p, 2p plus 2, and 5p plus 3. So let's map it out. So here and here. the formula for our constant difference is T2 minus T1. And over here, it's equal to T3 minus T2. So let's sub in T2 and T1 over here. We have 2p plus 2 minus p. This becomes 2p plus 2 minus p. Sorry, let me move this down real quick. And this simplifies to p plus 2. Now on the right side, we have T3, which is equal to 5p plus 3, minus T2, which is 2p plus 2, equals 5p plus 3 minus 2p minus 2. Don't forget to sub that minus in there. Okay, this gives us 3p plus 1. Now, because it's an arithmetic sequence, we know that this constant difference and this constant difference have to be the same. Because in an arithmetic sequence, it stays the same. It doesn't change. It's always the same. So if you looked at our other examples, it was always 2, 2, 2, or -4, -4, -4. It stays the same. So in the first question over here, it says calculate the value of p. We can immediately make this equal to this. We're going to say p plus 2 is equal to 3p plus 1. And then we're going to solve for p. So I'm going to move the p to the left. So I'm going to move this over, and it's going to become negative 2p is equal to 1 minus 2, negative 1. And then p is equal to 1 over 2. Okay, so the next question asks us to determine the sequence. So what they're asking us to do is they want us to determine this sequence. And obviously, we now have p. So we can put that back into here and we will get our sequence. So we know that the first term was equal to p. So T1 is equal to p, which was a half. That's the first one. Okay, so T2 is equal to, we know that it was 2p plus 2. So we're going to sub in a half into p like we did with the first one. And this is going to give us 1 plus 2, so the second term is equal to 3. Now T3 is equal to 5p plus 3. So we're going to do the same. We're going to sub in a half into p. And if you put this into your calculator, it gives me 11 over 2. And that's the answer. That's the sequence. So the sequence goes a half, then 3, then 11 over 2. Okay, so this next question asks us to find the 49th term. Now we don't have the formula for the general term, so I would suggest let's find that first. So we're going to say Tn is equal to a plus n minus 1 d. So now we can see that the first term is equal to a half, and our constant difference, how do we get from here to here? We're adding 2.5, which is the same as 5 over 2. So that is our constant difference now. That is our new constant difference. It's equal to d. Right? We're adding 5 over 2 the whole time, which is the same thing as 2, 5. You're adding 2, 5. So the constant difference is equal to 5 over 2. Okay, so let's solve this. We have Tn is equal to a half plus 5 over 2n minus 5 over 2. So we have Tn is equal to 5 over 2n. Okay, so now to find the 49th term, that is a position. So that is where n is equal to 49. So to find term 49, we're going to sub into n. 5 over 2, 49 minus 2. Term 49 is equal to 241 over 2, which is the same thing as 120,5. Same thing. Now, which term is equal to 100.5? We want to take our general formula that we figured out, and we want to make it equal to 100.5 because we want to find out which term, so the position of the term that is equal to 100.5. So our general formula was equal to 5 over 2n minus 2. So 100.5 is basically 201 over 2. So we're going to say 201 over 2 is equal to 5 over 2n minus 2. We can get an LCD here and say 201 is equal to 5n minus 4. So we've multiplied everything through here by 2. Once we've got this, we can solve for n. So when we take the 4 over, we end up with 205 equals to 5n, and we divide by 5, and we get 41. So this is the 41st term that is equal to that. Okay, so here's a word problem we can solve. A ladder has 11 equally spaced rungs. The rungs decrease in length from rung to rung. The lengths of the bottom and top rungs are 70 centimeters and 50 centimeters respectively. Which rung, counting from the bottom, has a length of 58? So first things first, I'm going to quickly sketch this out so we get a good idea of what we're dealing with. They say the lengths of the bottom and top rungs are 70, the bottom, and 50, the top. So this is 50 centimeters. This is 70 centimeters. Now, they say counting from the bottom, so that's from here, which means the 70 centimeter rung is going to be our first term. And because there's 11 rungs, the top one is going to be T11. It's going to be our 11th rung. Okay, so let's write out a number pattern for this situation. We have our first term is equal to 70. Our second term, we're just going to add a constant difference. So it's going to be 70 plus d. Our third term is going to be 70 plus 2d. And our fourth term is going to be 70 plus 3d. Because our general formula is written like this, our a value is going to be equal to 70 plus n minus 1 d. And we know that at position 11, Tn is equal to 50. The length of it is equal to 50. So we can sub these two into here to calculate d. So where Tn is, I'm going to sub in a 50. And where n is, I'm going to sub in 11. And then I can calculate d. So I'm going to move the 70 across. I'm going to end up with negative 20 equals 10d. d is equal to negative 2. Now I can get my general formula. Tn equals a plus n minus 1d. Tn equals, the length of the first was 70 plus n minus 1 negative 2. Tn equals 70. We're going to sub that negative 2n. It's going to be negative 2n plus 2. And our formula is negative 2n plus 72. And that's our general formula. Now, the original question asked us which one has a length of 58. So we are going to sub that into Tn. They're asking us for the position where it's equal to 58. So we're going to make it equal to 58, and we want to calculate the position. So when we take that 72 across, we end up with negative 14 equals negative 2n, and divide by n on both sides, and I end up with 7. So the 7th rung is equal to 58. And that is your answer.